Hello and welcome again. So for this time we're going to talk about relative extrema and convexity. So to start off we're going to talk about a bit the anatomy of a function. So imagine we have our x and y axis, so this is x and this is y, and we have a function such as this. Okay? So what we see here, and this function has many things. So to start off, it has maximums and minimums. So maximums and minimums are points in a graph where they are, well, as the name says, it at the minimum or maximum point of it. So then here, right here, we have a minimum point because the point right here is higher and this one as well. So in this point, imagine it's y equals 6, we have a minimum. Well, here, the same concept applies, but as a maximum. So this point is lower than this point, and therefore, this is the maximum. Maximums and minimums can be recognized because their slope is 0. So here we can see the tangent line. Imagine this is, I don't know, the function of this would be y equals 6x plus 3, plus minus 3. So in this case, minus 6x minus 3, sorry, that would be the correct way to say it. This would be, this is a downward sloping slope, obviously. Well, here what we have is we have a horizontal slope. There's like, the slope is y equals 0. So this is something to take into account when doing, when understanding minimums and maximums. Then, what do we also have? We also have inflection points. So inflection points are points where the graph is starting to change the tendency. So what we see here, we have the graph is going down, then it's going up, then it's turning down again. And what we see is that here it's growing, but at one point it's starting to grow at a lower rate. This right here is the inflection point, where it is where the second derivative is equal to 0, but we'll see that further on. And lastly, we have concavity. So we have concavities to which way the curve is looking. So we have concave up, which would be like this, and concave down, which is like this. So here what we have is we have a concave up until the inflection point, where after the inflection point, the graph is concave down. Okay? So now to look at it with an example, what we have here is we're going to start with a function. So the function is minus x to the third power plus 9x squared minus 24x plus 2. Okay, so now what they're asking for us is to find minimum and maximum points. So minimum, max. So how do we do this? Minimum and maximum points are found when the derivative of this function is equal to 0. So how are we going to do this? What we're going to do is we're going to start by deriving this function. So this, as has been taught in different classes, we just simply derive. So this would be minus 3x plus 18x minus 24. If you don't know how to do this, please go to the previous video where you can see how it has been done. And from here, what we're going to do is we're going to equal this function to 0. Okay? So f prime of x is equal to 0. Therefore, minus 3x squared plus 18x minus 24 is equal to 0. By using your calculator, by using logic, by using the normal quadratic function, you can find that x is equal to 4 and x is equal to 2. Okay? So this is what our graph would look like. Our graph would look like something like this. So it would end down here, up here, and like that. So what we see is, we should probably move this. What we see is that we have two maximum, one minimum and one maximum point. One minimum here, one maximum here. So now all we have to do is find out how to know which if the 4 is the minimum or the 2 is the maximum. So basically, how we're going to do this is by drawing the graph in a simpler way. So what we have here, what we're going to do is we're going to draw the derivative in a simpler way. So what we have is, we're going to do just a simple line, and we're going to drop the derivative. So in this case, our derivative is minus 3x squared plus 18x minus 24. Okay, so this graph would look something like this. This is a quadratic function with the negative on the x squared, meaning it's downward slope. It's sloping down. It's concave down, in fact. So here we have, we would put the points 2 and 4. So if you remember from previous classes, what you have is that the derivative shows the slope of the graph. So whether it's growing or not, or it's not growing. So here what we have is that the derivative from here down is negative, meaning the graph itself is going down. Therefore, here we can understand that the graph here is going down from before point 2. Now from point 2 onwards, the derivative is positive, meaning the graph is going up. And from point 4 onwards, the derivative is again negative, meaning that the point is going down. So what we have here is that the graph is decreasing, then increasing, then decreasing again. So this is exactly what we have here. So in point 2, what we have is a minimum, because here it's decreasing, and then increasing again. So this is x equals 2. And for x equals 4, it's increasing and then decreasing again, meaning that the graph is x equals 4 is a maximum. Okay, so this is how we find maximums and minimums. Now, what they also ask is for us to find inflection points. So inflection points are found by getting the derivative and getting the second derivative. So it's the same concept, it's just simply doing it again and again all the time. So you have this f prime of x, and we're going to get this function here, which is our derivative, and we're going to derive it again. So what we have is minus 3x squared is equal to minus 6x plus 18x is plus 18, and this we just completely ignore since it's just a constant. So this is what we have. So what we're going to do is we're going to equal this to 0, because inflection point is equal to f prime of x is equal to 0. Okay? So for that, we're just going to equal minus 6x plus 18 to 0, and what we get is x equals 3. So at x equals 3, we have an inflection point. So we would see it from the graph we had before. We had the minimum and the maximum here. This would be the inflection point. So yes. And last thing we need to find out is whether a function is concave or convex, or concave up or concave down. So how are we going to do this? So to find out whether a function is concave up or concave down, we need to once again use the second derivative. So when f prime of x is less than 0, the function will be concave down, meaning it is like this. When the second derivative is f x is 0 and it's greater than 0, the function will be concave up. So imagine they ask at the same function we have here, they're going to ask at point x equals 4, is it concave up or concave down? So it's as simple as just simply doing f prime of the point was 4, and you just plug it into this. So we get minus 6 times 4 plus 18. And what we have is that x is equal to minus 6. And since it's negative, as you can see here, the graph is concave down. So that's it for relative extreme and convexity, and in general, how to analyze a graph. See you in the next video.